Everybody, I'm going to go over stereocenters and RS configuration in this video. So the first thing to keep in mind here is that stereocenters are also called stereogenic centers and also called chiral centers, okay? So you might see any of these three names for the same thing. So what any of these three crazy names are, we're looking at tetrahedral sp3 carbons that are bonded to 4 different groups, okay? So sp3 is a really big point to keep in mind here. If it's sp2, you can only have a maximum of 3 things attached to it, right? So at that point, it's not going to ever be a stereocenter because we're looking for 4 different groups. So we're looking at sp3 atoms here. Okay, so let's look at this and try to see what stereocenters we have in these 2 molecules. Okay, so if I start over here, that's a CH3. That does not have 4 different things. It's got 3 hydrogens, right? But if we look at this one, this has a CH3 on it, CH2, CH2, H. Okay, and let's draw in the H. So you might look at this and say, well, these 2 are the same, so it's not a stereocenter. But if they are identical, you need to keep going along the chain until you find a point of difference or you reach the end of the chain, okay? So if we go here, then we say, okay, well, those are the same. So then we go here, and you could probably argue to me that those 2 CHs are the same. But once we hit here and here, those are certainly not, okay? So we have to travel along this entire path until we find a point of difference or hit the end. But once I hit here, I have found a point of difference and these are different, okay? So this is a stereocenter right here, okay? So if we think about that, that's just got 2 H's on it. That's a really quick way of finding the end of a road, right? Is there's my end. Those 2 are identical. We're not moving forward. But then let's look at this one. So this is attached to a ketone, CH2, CH, and then, oops, an H. That's going to be a stereocenter. Okay, that's got 4 different things on it. And then if we look at this one, we've got this carbon, which is next to the ketone, this CH2, that CH2. But if we're looking to see if this and this are identical, we can move on to the OH versus a carbon. Those are different. Okay, so then we have one here. This carbon is again another CH2. That's not going to count. This oxygen does not have 4 different things around it, so that's not going to work. And then this carbon is a CH3, and this one is sp2. Okay, so this molecule has 3 stereocenters on it. So let's look at this one. So if I'm here, all of these are CH2s. Okay, so the only hope that I have of something different here is this carbon right here. So it's definitely got an OH and an H, right? So I've got at least 2 things on it. But if I go CH2 to CH2, those are the same. So let's continue on. CH2 to CH2, those are the same. And then if I come to the same atom here, this path and that path are exactly the same, okay? There is no stereocenters present here. Okay, because this is the same as this, right? So if we're traveling around, we meet back up and nothing was different along the way, then that's not what we're looking for. Okay, so now that we can identify stereocenters, we need to figure out how to accurately communicate whether those stereocenters are like on a wedge, on a dash, what exactly are they doing, okay? And that comes down to what configuration are they? So we talked a lot about conformation last week. Configuration can only happen by like taking your model apart and putting it in a different place, okay? Conformation, we were doing all kinds of bond rotation events, but nothing was actually like breaking, right? But if we're looking at configuration and not conformation, this is the actual like, is it up or down, okay? So this can only be changed by breaking bonds. not bond rotations. Okay, so we're looking at something where you actually have to physically remove it and reattach it. So the process of doing this, it is really important because we need to be able to tell the difference between two enantiomers, for instance, or diastereomers or whatever. So we have to have some way of communicating what our different stereoisomers are. Okay, so R and S is the way that chemists have kind of decided to agree on how to do this. It's a bit of a nitpicky process, but you know, that's the way it is. So the first thing we would need to do is rank our atoms in order of priority. Okay, so we're using atomic number for this. Okay, atomic number is going to be the way that we list our priority. Highest atomic number is going to be number 1. So 1 is highest priority. 4 is going to be the lowest atomic number. Oftentimes that's going to be a hydrogen. Okay, we want our lowest priority group to be on a dash. So we want it to be facing away from us, not towards us. Okay, and that just makes sure that everybody's looking the same direction, right, when we're trying to assign these. So then once you have your priorities 1, 2, 3, and 4, you're going to draw arrows from 1 to 2 to 3. And if that's clockwise, it's going to be R. If you go 1, 2, 3 counterclockwise, it's going to be S. Okay, so there's different ways that you can remember that. I know that one that people tend to giggle at a little bit is if you think scounter. Like, I don't know why, but a lot of people were like, oh yeah, scounter, that makes sense. But okay, whatever, that's fine. However you want to remember it. We just got to remember it. So let's look at a couple of examples, and there's going to be a few kind of tricks that I'm going to show you along the way. So we're going to start off with a couple of enantiomers. So these two molecules that I'm going to draw are both carbones. And if you've never heard of carbones before, they are the scent flavor molecules of spearmint and caraway. So the interesting thing about them is that they are enantiomers of each other, but obviously have very different tastes and smells associated with them. But all they have different in them is this stereocenter, which I think is really cool. Some people might not think so, but our taste and our smell receptors that we have in our bodies are all chiral environments. So these chiral molecules are going to interact differently in them depending on their 3D shape, right? I think it's fascinating. Okay, so we've got these two enantiomers here. We first got to identify our stereocenter. Okay, so our stereocenter is right here and right here. One way that you can kind of cheat that is look for wedges and dashes. That's generally going to kind of help guide you. But you can also just do quick looks of like, well, these are all sp2. That's a CH3. That's a CH2, CH2, CH3, sp2. So we're basically left with that, right? That's our only option. So we've identified our stereocenter. So we need to do some ranking now. I always draw in the H for these. Like, it's always draw in your H. There's no reason not to. So if my substituent here is on a wedge, my H is on a dash, which is awesome because I've got my lowest priority group on a dash already. Because if I'm looking at carbon versus carbon versus carbon versus H is going to be number 4. Okay, so let's talk about the priority of the other ones. So I'm going to do a little bit of creative highlighting here. And I'm going to label some stuff out. So we're going to go A, B, C. Okay, so I try to do this as systematically as possible so that we can kind of follow along how to prioritize things, because it is by far the most aggravating part of this process. So what I encourage you all to do is you want to be very methodical about this. Don't try to rush it. Just try to take your time, take notes along the way so that you don't get yourself lost. Okay, so what we're going to do is A, B, and C, they are all carbons, right? Those are all carbon atoms. So what we're looking at here is, since they're all carbons, it's very hard to tell how we're going to rank them. So what we need to do is we need to look farther along the chain and start determining that. So what we're going to do is we're going to look at these 3 carbons. We're going to start with A, and we're going to ask ourselves, okay, what is attached to A that's not moving back to the stereocenter? Okay, so like we know that it's attached to this carbon, but we're really looking at what are the other 3 things that it's attached to. So in this case, we've got a hydrogen, and a carbon. Okay, so in A's column, we're going to write H, H, C. Okay, so let's do the same thing for B. So in the case of B, B is an sp2 carbon. Okay, so the way that we deal with that when we get to it is we're essentially counting each bond to that to a carbon as 1 carbon. Okay, so this pi bond, again, we're not looking back towards the stereocenter, we're looking away from the stereocenter. We're going to go, okay, that's a carbon, carbon, carbon. So we're going to have 3 carbons on that guy. Carbon, carbon, carbon. Okay, and then for C, we've got another situation of H, H, and then C. Okay, so H, H, C. Okay, so at this point, we have one that's coming out as a higher priority item. Okay, this one, we essentially have these H's are going to cancel out. These carbons, they're equal, but this is the highest priority of all of them, right? Because we have carbons beating out hydrogens is what we're looking at. So this one is our winner. This one is our number 1. Okay, so now we need to figure out 2 and 3. Okay, so because of that, because these 2 are still identical, we need to move next in the chain. Okay, so we're looking at, let me just make a little note here. So we were looking here for that one. Let's go pink. Now we're looking here for this next row. Okay, so we're only looking at A and C now. B is out of the picture because it already run. It already won, sorry. Okay, so A, if we're looking at this carbon now, again, we're counting pi bonds twice. So this is oxygen, oxygen, carbon. And again, we're not moving backwards. We already counted that stuff. So oxygen, oxygen, carbon. And then this one, we've got carbon, carbon, hydrogen. Okay. As soon as we have 1 oxygen here where this just has carbons and hydrogens, that's going to win. Okay. The really important thing to note here, we are not looking at overall mass. We're looking at atomic number, and we're looking directly when the differences hit. Okay. Because if we're looking at this, like this would have beat out B, but it didn't beat out B soon enough. Okay. So B won against the first hurdle where we had the first difference. So now it's already won the game, and A is going to be number 2. Okay. Just because that priority group was farther away. So we're only looking at the differences as soon as they come. And once we find a difference, we stop. Okay, it's no longer anything that we're looking at. So now we have our priorities. So A is 2 and C is 3. Okay, so now we go ahead and we draw our circle. So we're going to go 1 to 2 to 3, and that is going clockwise. So since I have my H in the back, that's going to be R. Okay, so that's what I'm looking for this assignment. That stereocenter is R. So this is R carbon. And that's essentially how we would tell people which enantiomer we're working with, because we're saying it's the R one. And then people know how to draw that based on that information. Okay, so let's look at the other side, the other enantiomer here. Okay, so we have a very similar setup. And let me just, there we go. So we have a very similar setup here, pretty much the same exact molecule. So the nice thing is, if we've already assigned priorities, that's not going to change in the enantiomer, okay? So we don't need to do all of that again. We do need to draw the H in. So notice what we have going on here is that the H is now in the front, okay? If the H is in the front, we need to be considering that along the way, because our rules specifically say place it on a dash. If it's on a wedge, we're going to have to deal with that, and we'll talk about how to deal with it. So again, we've got 1, 2, 3, 4. Okay, so this arrow that I've drawn here has not changed. But let's look at a model of how we want to think about that. So what I like to do, I'm going to first put it together on this, and then I'm going to stop the screen share. We want to have our model kit, and like all you need is a single tetrahedral carbon. So what I like to do is I like to have red, white, and blue, just because then I can go like red 1, white 2, blue 3, so that I know what direction to go. So what I do, and what I'm going to try to get through on this, and we'll see if I can do it on the camera, is I'm going to take these off first. Okay, so the way that I have this drawn, I've got carbon, carbon in the plane, and then wedge dash, okay, at the bottom. So 4 is my wedge, so that's going to be the one pointing at me, and I'm going to make that the one pointing at you. And then 1, which is going to be red, is going to be pointing away from you. So red is 1. White is 2, which is the one that's over here. Ooh. This is so hard in a mirror. Okay. And then 3. Just check to make sure. I'm gonna pause this. I gotta think about this for a second. Alrighty, I figured it out. I just had to think in enantiomers, and then I was okay. All right, so if I'm here, oh, let me stop the share. Actually, I'm gonna line it up first. Okay, so what we have going on here, we've got H in the front, so that's my H, and then 1 is red, pointed away from you. 2 is white, which is on the left, and then the blue is 3 on the right. Okay, so this is exactly how we have it set up in the R version, right? Except the H is here. Okay, so in the R, we had the 1, 2, 3, 4 going clockwise, right? So basically what's happening here is we went red, white, ugh. Okay, let's not talk about the enantiomer. Let's talk about this one. Okay, if I have H in the front and I go red, white, blue, that is going clockwise. Okay, red, white, blue. But H is in the front. That's not where I want it to be. It should be in the back. So if we switch it to the back of you, then I've got red, white, blue, and I'm going counterclockwise. Okay, going opposite. So if I'm going counterclockwise when H is in the back, and I'm going clockwise when H is in the front, if I have my H on a wedge, I just swap the RMS configuration. Okay, you can do the same kind of assignment on paper, but if H is on a wedge or your number 4 is on a wedge, switch it from R to S or S to R. Okay, and it's just because you're looking at it here where you're going red, white, blue clockwise. And then when you put it with the H actually in the back, you're going red, white, blue counterclockwise. Okay, it's just this versus that. So that assignment is going to be, so we're going clockwise here, right? That's clockwise, but H is in the front, so it's S, okay? And that's the kind of process that we want to go through. So if H is in the front, we're just going to switch what would have been R to the S. Okay, so the last thing that we need to talk about here with R and S is what you need to do when your H is not on a wedge or a dash. Oops. But instead when it's in the plane. Okay, so this H is in the plane of that carbon ring. It's in the plane of the screen right now. And my wedges and dashes are my CH3 and my OH. So if I have my H in the plane, none of those two tricks are going to help you. So there's a couple of things that we can do here. One, you can do a double switch. So I think that your book talks about this. When you do a double switch, you have to swap everything at the end, okay? So if we're looking here, I can switch, so let's do double swap. So I can swap and I'm just gonna delete that for now. Oh, what am I doing? Okay, so you just basically want to start with kind of the general setup that you had where you had the two bonds in the plane, two bonds on wedge and dash. And we're going to swap the H for the thing that's in the back. So we're going to put H back here and put CH3 here. But that also means that we need to swap the OH and the ethyl group. Okay, so that means we're going to have OH over here and ethyl there. Okay, so we swapped these. And then we also swapped these. Okay, and we kept everything else about the setup the same. So now our H is in the back. So now let's go ahead and do our assignments here. So at the first glance, I can do number 4, that's going to be H. Okay, then I'm looking at oxygen versus carbon versus carbon. So oxygen is going to win that one. And then for 2 and 3, this carbon is connected to 3 H's. This carbon is connected to 2 H's and 1 carbon. So this is going to be our number 2, our number 3, and then we can go 1, 2, 3. And we have that going clockwise. So that is going to be R. Okay. Because there's nothing funny going on. We've got the H in the back. We're all good. So the other way that you can do it is, again, your model kits. Okay, so I'm going to just start by making the enantiomer according to my viewpoint, and we'll see how that goes. Okay, so H, OH is going to be red, red, white, the sky, and then number 3 is in the back. Okay, so I did this from the camera perspective, so it should work out okay. So this is what we have, right? So this is our alcohol going towards you. The white is our ethyl group, that was our second priority, and then the blue is our third priority, and then 4 is my hydrogen that I'm holding. So you can see how difficult it is to like see this on paper in terms of like, is that clockwise or counterclockwise? But once you have the model of it and you've matched it up to your compound as carefully as you can with your 1, 2, 3, 4, then all you need to do is just change it so that you're looking at it with the H in the back. So if you were holding it for yourself, you would look like you're holding like this. But since I'm holding it for the camera viewpoint, we're going to look at it like that. So if I'm going red, white, blue, you can see I'm going clockwise. Okay, so it's going to be R. The models definitely make this a lot easier, and I can make it look a lot easier than this in person. It's just hard with a mirrored camera. But that's how I would recommend doing the H in the plane. You can do the double swap, but I think just making a model where like you know which number equals which color is way easier. So again, we will talk more about this, and I'll see you all later. Let me know if you have any questions.